This section is 7.3, trigonometric substitution. So you're going to have different cases. These are the three different cases, the first, the second, or the third. And then they'll tell you what substitution to make and which identities to use. All right, so for this first one, as you can see, it's in the form of 9 minus x squared, which means we want to go with, this is your 9 minus x squared. So therefore, our substitution needs to be x equals a, which is the square root of the square root of this number, which is 3. Because a squared is 9, therefore a is 3. So this would be 3 sine theta. All right, if you differentiate, you're going to get dx is equal to 3 cosine d theta. And then we're going to rewrite the integral as the integral of x squared, which means you have to square this, which is 9 sine squared, over 9 minus 9 cosine squared theta. Oops, sorry, sine squared theta. And then, so we took care of this part, that's here. Now we still need to dx. We got to substitute this in for dx. So that would be 3 cosine theta d theta. All right, now you can factor out a 9 from here, and then when you factor out the 9, you can take the square root of the 9, which becomes 3 on the outside of the square root. So that's going to make the integral look like this. 3 radical 1 minus sine squared theta, 3 cosine theta d theta. This can be written as cosine squared, as you can see from here. That's substitution. And then when you take the square root of cosine squared, you get cosine. So finally, our integral will look like this. So once again, what I did here, I replaced this with cosine squared theta. But when you take the square root of the square, it becomes just cos. All right, and now we can do some cancellation. 3 cosine cosine. And now we have 9 sine squared. The 9 can be written outside of the integral. Sine squared can be written as 1 minus cosine 2x, 1/2 times that. So the 1/2, I'm just going to move out to the front of the integral. So that's going to be 9 over 2. Sorry, this should be theta. All right, so the antiderivative of that would be theta minus 1/2 sine 2 theta. All right. I'm going to go ahead and distribute the 9/2. So now that would look like 9/2. And this would be 9/4. Okay, so far we have that. All right, and now we would, so now what we got to do is we got to write everything in terms of x, because the original integral is in terms of x, not in terms of theta. So we have to rewrite this in terms of x. Don't forget your constant of integration. So in order to write things back in terms of x, it's a good idea to draw a triangle here, a right triangle, and label it. There's your theta. And because of our substitution, that means that sine theta is x over 3 if you divide both sides by 3. And then you can label your right triangle. So sine is opposite hypotenuse, so that would be opposite over hypotenuse, opposite over hypotenuse. And then if you do the Pythagorean theorem, you'd get 9 minus x squared square root. So a squared plus b squared is equal to c squared. All right, and this is how we're going to rewrite theta in terms of x. So theta is going to be the inverse of x, inverse sine of x over 3. So that's going to equal 9/2. Theta is inverse sine x over 3. I got that from here. I just took the inverse of sine of both sides, and that's how I got inverse sine of x over 3 for theta. For sine of 2 theta, we're going to use the identity, this identity. Okay, so this is the identity we need to replace sine of 2 theta down here. So if you do that substitution, this will become sine theta is x over 3. So this will be x over 3. And then cosine theta will be this over this. So let's just write that in now. So it's going to be, hopefully I have space here to operate, minus 9/4. So I'm replacing this with this. So there's a 2. So times 2. Sine theta would be, we said, is x over 3. That's what sine theta is equal to. Opposite hypotenuse. And then cosine theta is equal to this over this. So 9 minus x squared over 3, I believe it was. Yes. All right, and then don't forget your plus c. All right, looks like we can cancel the 9 with the 9. 3 times 3 is 9. The 2 goes into the 4 twice. So our final answer will look like this. 9 over 2 sine inverse x over 3 minus x 9 minus x squared over 2 plus c. And that will do it. All right. So that is our final answer. Now let's move on to the next problem. So once again, refer to the table up above to see what your substitution should be. Notice that it's in the form of radical 4 plus t squared, which would be constant plus variable squared, which would be the middle one. So that means our substitution needs to be x equals a tan. So x equals 2 tangent theta. So 2 because this is your a squared, and so the square root of 4 is 2. All right, so now let's find the derivative. Dx d theta is going to be 2 secant squared theta d theta. And now we can, well actually this should have been a t substitution instead of an x substitution. T because of the variable is t, not x. All right, and now we can rewrite this as, well, we also have to change the limits because this is with respect to t, but now we're going to change it to respect to theta. So if you plug 0 in for t, you're going to get 0 equals 2 tan theta equals 0, 0, theta equals 0. So our lower limit is still going to be 0. And then for 2, you're going to get 2 equals 2 tan theta. I'm just plugging in 2 for t. And then if you divide both sides by 2, you get tan theta equals 1. Theta is pi over 4. So those are our new limits. 0, pi over 4. dt becomes 2 secant squared theta d theta. The denominator becomes 4 plus 4 tan squared theta. So I just substituted t into here, and that's how I got 4 tan squared theta. You can factor out the 4, and then when you take out the 4 out of the radical, it becomes 2. So the integral is now and then the square root, 1 plus tan squared. We're going to use the identity, this identity is secant squared. And then the square root of secant squared is just secant. Oops, no squared. So once again, this became 1 plus tan squared after I took out the 4. And then 1 plus tan squared is secant squared. And the square root of secant squared is just secant. All right, and now we can cancel some things out. 2 secant with 1 secant. And so now we're left with the integral of 0 pi over 4 secant theta d theta. For this, there is a formula for the antiderivative. I'm not going to go through the integral of this. It's going to be some type of, you're going to have to multiply top and bottom by secant plus tan theta, and then you would distribute and do a u substitution. But there's a formula that you can use for this, and it turns out to be ln, absolute value of secant theta plus tan theta. All right, and then we have to evaluate that from 0 to pi over 4. All right, looks like I'm running out of room, but let's see if we can do this. I'll just move this up here since there's a little space. So that's going to be ln of secant pi fourths plus tan pi fourths minus, this is going to turn out to be 0. If you plug in 0 here, the secant of 0 is 1. And then the tangent of 0 is 0, and the natural log of 1 is 0. So this is going to turn out to be 0, which we don't have to write out. And the rest of this we can evaluate. This turns out to be 1, and this turns out to be radical 2 over radical 2, which is really just radical 2. If you multiply top and bottom by the radical 2, you end up with radical 2. So our final answer is going to be natural log of radical 2 plus 1. The absolute value, since this is a positive number, you don't really need absolute value at that point. You can just use parentheses instead. And that is our final answer. And that is the end of this section.